The awakening sun. In my previous video, The Shield That Keeps Us Alive, we explored the invisible barriers that protect life on Earth, the sun's heliosphere and our planet's magnetic field. We saw how these shields have failed before, during the Lashamp event 42,000 years ago, and how their weakening today could threaten civilization. Since that video, new developments have forced scientists to rethink everything we thought we knew about the sun. Solar cycle 25, predicted to be mild, has turned into the strongest and most surprising cycle in decades. These new events are not just interesting details for astronomers. They are direct stress tests of Earth's defenses, and they prove that the concepts we explored before are not theoretical. They are unfolding right now. Let's start with the predictions. Back in 2019, NASA and NOAA released a forecast for solar cycle 25. They projected a maximum of about 115 sunspots, expected in mid-2025. That would have made it a weak cycle, similar to or even quieter than cycle 24. Many believed the sun was entering a long, subdued phase. The forecast sounded reassuring. But by late 2022, the data was already diverging. Sunspot counts were climbing faster than expected. By 2023, it was clear the forecasts were wrong. Then, in October 2024, NASA and NOAA made a stunning announcement. Solar maximum had already been reached, months earlier than projected. And not only early, but stronger. By August 2025, sunspot counts reached their highest levels in 23 years, shattering expectations. The official prediction of 115 spots had been blown away. The sun was far more active than scientists anticipated, and sunspots were only the beginning. Solar flares surged. In 2020, the sun produced just a few hundred flares. By 2025, the number had skyrocketed to nearly 3,000. 11 of those were X-class flares, the most extreme category, each one capable of disrupting radio signals, knocking out satellites, and endangering astronauts. The violence did not stop there. Coronal mass ejections, or CMEs, giant eruptions of charged plasma launched into space, multiplied. Some missed Earth. Others struck directly, producing geomagnetic storms and vivid auroras. But the most dramatic occurred in September 2025, a Cannibal CME. This is when one CME overtakes another, merging into a superstorm. When it struck Earth's magnetosphere, it unleashed auroras visible across Europe, North America, and Asia. Skies lit up far south of the poles, in regions that rarely see such displays. These events are more than beautiful spectacles. They are warnings. Every aurora at low latitude is evidence that Earth's magnetic shield is being pushed to its limits. Every flare and CME is a reminder that our planet's defenses are finite. Meanwhile, NASA's Parker Solar Probe has been flying closer to the sun than any spacecraft before it, plunging into its outer atmosphere. Its discoveries are rewriting textbooks. It confirmed that solar flares and CMEs are powered by magnetic reconnection, tangled magnetic lines snapping and reforming with explosive force. For decades, this was theory. Now it is observed reality. Even more surprising, Parker's data suggests the sun's magnetic fields may not originate deep in the core, as long believed, but closer to the surface, within just 20,000 to 30,000 kilometers of the photosphere. This new understanding helps explain why forecasts failed. The models were built on assumptions about where and how magnetic fields are born. If those assumptions are wrong, so too are the predictions. For us, the meaning is simple. We are living through a solar cycle that defied every forecast. It arrived early. It is stronger than expected. And it is producing storms more violent and more frequent than most living people have ever seen. Cycle 25 is not finished. It will continue to peak through 2025 and beyond. And if long-term cycles like the century-scale Gleisberg cycle are entering a new active phase, as some studies suggest, this could be just the beginning of decades of heightened solar activity. The sun has awakened. And its awakening is a direct challenge to Earth's shields. Revisiting the shields. Life on Earth is possible only because we live inside two shields. One is vast, powered by the sun itself. The other is close, generated deep inside our planet. Together they hold back storms and radiation that would otherwise strip away air, water, and life. The first shield is the heliosphere, a bubble inflated by the solar wind, extending far beyond Pluto. It slows and deflects galactic cosmic rays, particles moving at nearly the speed of light, born in the depths of distant stars. Without this shield, the solar system would be flooded with lethal radiation. But the heliosphere is not constant. It expands and contracts with the solar cycle. When the sun is active, the bubble strengthens, pushing cosmic rays outward. When the sun weakens, the bubble shrinks, allowing radiation to seep inward. The second shield is Earth's magnetic field. Generated by the movement of molten iron in the outer core, it creates the magnetosphere, a magnetic cocoon that surrounds our planet. It deflects charged particles from the solar wind, funnels some toward the poles, and turns that energy into auroras. Without it, Earth would lose its atmosphere just as Mars did billions of years ago. The oceans would boil off, and the surface would be left bare under a deadly sky. Both shields are fragile, they fluctuate. They drift, they weaken. The heliosphere rises and falls with the sun's 11-year heartbeat. Earth's field shifts unpredictably, sometimes collapsing almost entirely. 42,000 years ago, during the Lashamp event, the field fell to less than 10% of its strength. Cosmic radiation poured into the atmosphere, the ozone layer thinned, and climates destabilized. Survival became a test humanity barely passed. Today, the balance is being tested again. Solar Cycle 25, far stronger than predicted, is pushing plasma storms into the heliosphere and slamming Earth's magnetosphere with unprecedented force. Each time auroras appear in skies that rarely see them, across Europe, across the United States, across Asia, we are witnessing the magnetosphere flexing under pressure. Each time satellites glitch or communications falter, we are reminded that the shield is not invincible. In my first video, I described these barriers as the foundation of life itself. That remains true. But now we can see with our own eyes, in the headlines, in the sky above us, just how fragile those foundations are. The sun is breathing harder, and the breath is shaking the sanctuary that protects us. These shields gave us the conditions to thrive, but history shows they have failed before. And the new storms of 2024 and 2025 suggest they are under stress again. The Lashamp reminder. 42,000 years ago, the shield collapsed. It wasn't a full pole reversal, but a catastrophic weakening of Earth's magnetic field, what we now call the Lashamp event. At its lowest point, the field shrank to less than 10% of its normal strength. With the magnetosphere gone, cosmic radiation surged into the atmosphere. Ionization spiked, the ozone layer thinned. Ultraviolet radiation scorched the surface. Climates shifted violently. Ice sheets advanced, rain belts moved, droughts and freezes rippled across continents. The consequences were written into life itself. Large Ice Age animals, the megafauna, began to vanish. Genetic bottlenecks show sharp population crashes across many species. Even humans were pushed to the edge. For our ancestors, survival meant retreat. Caves became sanctuaries, not only against predators and weather, but against a sky that had turned hostile. Just a few meters of rock could cut radiation exposure dramatically. Archaeologists believe it is no coincidence that some of the oldest cave art, carvings, and ritual symbols appear during this period. These markings may not have been idle creativity. They may have been memory, warnings left for future generations under a broken sky. Technological adaptation accelerated. Clothing became more protective. Tools grew more sophisticated. Hunting strategies shifted. Migration patterns changed, chasing the shifting climates. Humanity endured, but not without cost. Populations shrank. Some lineages disappeared forever. Those who survived carried the scars. In their DNA, in their culture, in their stories etched into stone. The Lashamp event was not just a magnetic anomaly. It was a survival crucible. It proved that Earth's shields can fail, and when they do, the consequences cascade through atmosphere, climate, ecosystems, and human lives. Why revisit this now? Because the new storms of solar cycle 25 are reminders. They show us auroras sweeping across latitudes that never see them. They show us satellites failing and flights being rerouted. They show us a shield under stress. And they remind us that collapse is not just ancient history, it is a possibility waiting in the future. Our ancestors survived by moving into caves and carrying memory forward in symbols. We too may be forced to adapt, but our challenge is larger. We are billions, bound to a fragile civilization built on satellites, grids, and networks. If the shield fails again, survival will require more than caves. It will demand foresight, technology, and cooperation on a scale humanity has never attempted before. The Lashamp event is not just a story of the past. It is a warning, and with every solar storm, that warning grows louder. Signs of weakening today. The Lashamp event shows us that collapse can happen. Modern science shows us that weakening is happening again. For more than a century, we've been measuring Earth's magnetic field with increasing precision. The results are clear. On average, the field has weakened by about 9% in the last 170 years. That might sound small, but in the delicate balance of planetary shielding, it is significant. The weakness is not spread evenly across the globe. In some regions, the field is far weaker. The most striking example is the South Atlantic anomaly, a zone stretching from South America to Africa, where Earth's magnetic field is unusually thin. Satellites passing through this region are regularly exposed to higher radiation levels. Instruments malfunction, systems shut down. Engineers program spacecraft to power down when they enter the anomaly just to survive the crossing. The field is also drifting. Magnetic north, once near Canada, is racing toward Siberia faster than at any point in recorded history. The poles have shifted many times before, but the pace of today's drift raises questions. Are we heading toward another reversal, or at least another collapse like Lashamp? At the same time, cosmic radiation inside the solar system is rising. During the weak solar cycles of the early 2000s, the heliosphere shrank, and galactic cosmic rays reached record highs. Even during strong cycles like the one unfolding now, cosmic rays are penetrating deeper than models predicted. For airline passengers and crew on polar routes, radiation exposure has measurably increased. For astronauts, the risks grow with every mission beyond Earth's magnetic shield. Cycle 25 is compounding the problem. Instead of a quiet sun guarding us with a strong heliosphere, we have a volatile sun launching storms while Earth's field continues to weaken. The combination is unstable, stronger flares and CMEs striking a more fragile magnetosphere, while higher levels of cosmic radiation seep in from beyond. The evidence is not theoretical. It is measurable, repeatable, and already affecting our world. Satellites are failing in radiation-heavy zones. Starlink lost dozens of spacecraft to geomagnetic storms. Airlines reroute flights during major solar events to protect crews and passengers. Power grids are known to be vulnerable, with geomagnetic induction already causing blackouts in the past. In my first video, I argued that Earth's shields were thinning quietly, steadily. Now, the data is louder. The weakening is accelerating, and the sun is delivering storms strong enough to test the shield in real time. The question is no longer whether the shield can fail. We know it can. The question is how far this decline will go, and whether civilization is ready for what happens if the weakening turns into collapse. Modern consequences of collapse. The Lashamp event shows what happens when the shield collapses in a world of small human populations, scattered tribes, and stone tools. But what would it mean if it happened today, in a world of satellites, power grids, and 8 billion people? The first sign would not be silence. It would be light. Auroras would no longer be confined to the poles. Curtains of green, red, and purple would sweep across skies near the equator. Cities that have never seen the northern lights would glow beneath them. The beauty would be haunting, because it would mean the magnetosphere was no longer holding back the storm. High-energy radiation would surge into the atmosphere. Ionization would shatter ozone molecules, stripping away Earth's ultraviolet shield. The sun's rays would reach the surface with lethal intensity. Crops would wither under genetic damage. Food yields would collapse. Ecosystems would unravel. At the genetic level, the effects would be just as severe. Cosmic radiation tears DNA apart. Mutation rates would spike. Cancers, birth defects, and heritable damage would spread across generations. Our ancestors could retreat into caves. We live in cities. The exposure would be widespread, unavoidable. The atmosphere itself would shift. Ionization alters how clouds form. Storm systems would grow erratic, violent, and unpredictable. Some regions could be locked into permanent drought, others hammered by unending floods. The stable climate window that supported agriculture for 10,000 years would fracture. Technology would fail first and hardest. Satellites would be fried by radiation, their electronics shorted and their orbits decaying as the thermosphere swelled. GPS navigation would collapse. Communication networks would falter. Weather forecasting would vanish. Space travel would become suicidal without massive shielding. On Earth, geomagnetic storms would surge through power grids. Transformers, the irreplaceable giants that keep electricity flowing, would burn out. Restoring them could take months or years. Blackouts would cascade. Cities, dependent on constant electricity, would face outages that stretch not for hours, but for seasons. Aviation would change overnight. High-altitude flights, especially near the poles, would become dangerous. Radiation exposure would make transpolar routes unsafe. Airlines would be forced to reroute or abandon them, fracturing global travel and trade. Food chains would fail not only from UV-damaged crops, but from the collapse of GPS-based agriculture, global shipping, and cold chain logistics. Populations in cities, where most of humanity now lives, would find food running scarce. Migration would begin. Families would flee irradiated zones and failed harvests. Borders would strain. Conflict would grow as nations competed for safe land, water, and resources. The pressure of billions on the move would test political systems and international cooperation like never before. This is not speculation. The pieces are already visible. Auroras at unusual latitudes. Starlink satellites deorbited by storms. Polar flights rerouted during solar events. These are small previews of what collapse would mean on a planetary scale. The shield has failed before. If it fails again now, the storm will not just be in the sky. It will be in the air we breathe, the soil we plant, the grids we rely on, and the bodies we inhabit. Our ancestors endured because they were few, mobile, and adaptable. We are many, interconnected, and dependent on fragile systems. The broken sky of the past was a crucible. The broken sky of today would be a collapse of civilization itself. Preparing for the storm. The storms are coming whether we are ready or not. We cannot control the sun. We cannot stop the drift of Earth's magnetic field. But survival has never depended on control. It has always depended on preparation. Preparation begins in space. Satellites, the nervous system of modern civilization, must be hardened against radiation. Shielded electronics, redundant systems, and smart orbital strategies can mean the difference between a functioning network and a cascading blackout. When Starlink lost dozens of satellites in 2022 after a solar storm expanded the atmosphere and dragged them down, it was a small preview of what unchecked storms can do. We must learn from it. Power grids are the next line of defense. Transformers, the heavy lifters of electricity, are vulnerable to geomagnetically induced currents. If they burn out, replacing them can take months, even years. Hardening grids with protective relays, surge arresters, and reserve transformers is essential. Some countries are beginning to prepare. Many are not. Food security is critical. Agriculture exposed to lethal ultraviolet radiation will fail. Underground farms, enclosed greenhouses, and radiation-resistant crop genetics must move from research projects to mainstream infrastructure. Just as past generations built granaries and food reserves against famine, we must build shielded agriculture against a broken sky. Medicine will become a survival tool. Radiation drives cancer, genetic damage, and birth defects. Treatments designed for astronauts may need to scale to entire populations. Genetic repair technologies, protective pharmaceuticals, and cancer prevention strategies must be accelerated. Even architecture may need to evolve. Cities with magnetic shielding. Subterranean facilities for shelter and agriculture. Infrastructure designed not just for comfort, but for survival when the atmosphere itself becomes hostile. But preparation is not only technological, it is cultural. 42,000 years ago, humanity survived by remembering. Cave art and ritual were more than expression. They were memory, warnings carried forward. If we forget, we are vulnerable. If we remember, we adapt. International cooperation is also unavoidable. Space weather knows no borders. A flare that strikes the United States also hits Europe, Asia, and Africa. One nation cannot protect the planet alone. Scientific data, survival strategies, and resilience frameworks must be shared globally, or collapse will be uneven and chaotic. Survival will not be easy, but it is possible. The shields are weakening, the sun is growing more violent, and the risks are real. But humanity has survived storms before. The difference now is scale. We must be proactive, not reactive. We must prepare before the broken sky arrives. Conclusion: memory and responsibility. 42,000 years ago, the sky broke. The shield collapsed, and survival was no longer certain. Humanity endured only by adapting, by seeking shelter, by innovating, and by remembering. They left us warnings in stone, memory carved into caves, so their struggle would not be forgotten. Today we stand under the same sky. The sun is stronger and stranger than expected. Solar Cycle 25 has shattered forecasts, unleashing storms that reach across continents. Auroras dance where they should not. Satellites falter. Flights are rerouted. The signs are here. Earth's shields are under stress again. Our world is not the world of cave dwellers. We live inside a civilization built on fragile networks, satellites, grids, supply chains, and billions of interdependent lives. If the shield falters now, the cost will not be measured in scattered tribes, but in the survival of civilization itself. We cannot control the sun. We cannot stop Earth's magnetic drift, but we can choose how we respond. We can prepare. We can harden our systems. We can shield our crops, our power grids, our satellites, and our people. And just as our ancestors left memory in stone, we must carry memory forward in culture, in science, and in planning. The storm is inevitable. Collapse is possible. Survival is a choice. When the shield is under siege, will we be ready? And more importantly, will we remember?